Good morning. Welcome to the 8th Native Prairie Restoration Reclamation Workshop. I am Carolyn Gadet, the manager of the Saskatchewan Prairie Conservation Action Plan, or PCAP. I'd like to start by stating we respectfully acknowledge that we are on the traditional territories of many Indigenous nations and communities, past and present. For a millennia, they have worked to protect these landscapes and the life these areas sustain. I would like to thank these original caretakers and acknowledge the ongoing work and presence of Indigenous peoples in Canada today. It's the 8th time that PCAP has hosted this event, but the first time that we've done it online. And so we're really excited that we are able to continue our workshop virtually while everyone stays safe during this global pandemic. This past year has been quite something. The planning committee decided on the theme of restoration and reclamation in a changing environment, adapting to change, building resilience. We thought it was fitting as we seem to always be in a state of change, whether it's because of a pandemic or climate change, shifting priorities, or newly elected political parties. We're often faced with challenges, and we wanted to highlight that to help deal with it in restoration and reclamation work. This event would not be possible without the longtime support of our platinum sponsors, Xerces Associates and the Mosaic Company. We are so grateful for all of our gold sponsors, Crescent Point Energy, Enbridge, Environment and Climate Change Canada, the Canadian Wildlife Service, the Faculty of Science at the University of Regina, North American Helium, PV Industries LP, Sask Energy, Sask Power, Sask Water, and TC Energy. Our silver sponsor for this event is Truax Company, and I would like to thank our bronze sponsors, Brett Young, CN, and Earthmaster Environmental Strategies, Inc. Our advertising sponsor, the Alberta Society of Professional Biologists, and our participant sponsor, the Society for Range Management Prairie Parkland Chapter. I'd also like to thank our planning committee for their hard work over the last year. They volunteer their work and personal time to this event, and we always appreciate their feedback and ideas. I would also like to especially thank Caitlin Moreau-Saylor, who is the stewardship coordinator at Saskatchewan PCAP, and who has been instrumental at helping pull this workshop together. She's very efficient, and I appreciate her dedication and effort. And a big thank you to our presenters and discussion group leaders for their contributions and support. There's more involved to participating in a virtual workshop. There's practice sessions dealing with IT issues, slightly demanding organizers who send multiple backup plan options if various issues are to arise. We gotta plan ahead. We're at the mercy of technology for this event, which is not something that we're used to. So we really appreciate their patience and their cooperation. We also appreciate all of the support from our attendees. We have over 270 individuals registered for this week who are from BC to Ontario, New Jersey to Idaho, and many of which are first-time attendees to our workshop. So welcome. We hope you enjoy it and learn a lot of useful information that helps improve your native prairie restoration and reclamation projects. Over the next week, you'll have access to over 25 webinars. I would like to encourage you to make the most of the networking experiences. So the poster session, the trade show, and the discussion groups. Virtual events are similar to in-person events in the way that you get out of them what you put in. So it might take more effort to visit the poster or a trade show booth and participate in the discussion groups, but you'll end up getting more out of it. And so to encourage you to explore our virtual event, we will be hosting an event passport contest. So it's kind of like a scavenger hunt that includes questions from our posters and exhibitors. And anyone who sends in their completed passport with the correct answers will be entered into a draw for a prize package from CN or a draw for free registration at our next Native Prairie and Restoration Reclamation Workshop in 2023. Now, just a few housekeeping notes. The workshop is 5 days this year, which we know is a lot, and we just wanted to cover a number of topics. and not have to make people choose which presentation they go to, because that's always an issue at in-person workshops. So you can take in the presentations you really want to attend, and then do work when there are topics that aren't relevant to your work. Most presentations will be recorded and available on the FeedLoop virtual platform for the next few months. So you are more than welcome to come back and rewatch a good presentation or watch those that you've missed. There are 2 presentations that will not be recorded, and those are the ones by the University of Winnipeg. So Colleen Robertson at 3 this afternoon, and Raphael Otfanowski and Vicky Coffey at 1:30 on Wednesday afternoon. So make sure to catch those live if you are interested. I would also like to remind everyone to download our event program from the PCAP website. There's also a link to the event program in the lobby. You might just have to scroll down to find it. This includes a detailed schedule for the week, presentations and discussion groups, greetings from our sponsors, and more. As we all learn to navigate this virtual platform, I encourage you to use your tutorial video and attendee guide. There are also links to both of those in the lobby. If you are experiencing IT issues, you can check out the help button located on the left-hand side in the dashboard, or contact Becky Magnus or Shirley Bartz, and they will contact IT support for you. IT support is only available on call today, so if you have any issues, please get them figured out today. I am now pleased to introduce Andrea Lacourcière from PV Industries LP to bring greetings.
Good morning, and welcome to the 8th Annual Native Prairie Restoration Reclamation Workshop. My name is Andrea Lacourcière, and I'm here to bring greetings on behalf of the Gold Level sponsor and my employer, PV Industries, which most of you may know better as PV Mart. We at PV depend on the stewardship of the prairies. Without it, we wouldn't have the generations of customers, families committed to the cultivation and conservation of these lands. The last place I traveled to before COVID-19 was declared a global pandemic was 2020's workshop. It was an eye and heart-opening few days for me in Regina. I was thankful for the drive back, as it gave me time to process and to sift through everything I had learned. I had no idea that goat insurance was so expensive, but also how I could take back and share with my team the important work that is happening in the field of reclamation and restoration of our prairies. We built our reputation over the last 54 years by being true to ourselves, to our customers, by remembering where we come from, always being forward-thinking, and showing deep respect for our land and for our customers. This is exactly where the stewardship of the prairies has brought us. Collectively, we must recognize the enormous environmental impacts that can be made through the carbon capture abilities of our native grasses, our wide open spaces. This is perhaps some of the most elemental and yet critical messaging we can take back to the public. We have 90 corporate stores across the country and a commitment to sustainability. We are here for the long haul and welcome the opportunity to engage in critical learning at every level. February is Black History Month, so I would be amiss if I didn't share with you one of my favorite quotes that seems quite timely by the revered Maya Angelou. Do the best you can until you know better, and then when you know better, do better. We will rise to the occasion as we have an obligation to do so. Thank you for the opportunity to connect. Have an excellent week of sharing, learning.
That was wonderful, Andrea. Thank you so much for sending in this video. It was very much appreciated. I also love that quote as it applies to everything in life. It's a great quote and a great reminder. Now, before I hand it over to our first speaker, I just wanted to let you know that you can move the AV pod where the webcams are so that it's docked on the panel on the right if it's obstructing your view of the presentation. Also, you can type in questions at any time in this chat pod, but the speakers will only be answering them at the end of their presentations. Also, if you have general comments about the session or workshop, those can be put into the public group chat on the right side of your screen. But the public group chat will not be moderated during presentations. You can also click the Hide All button, which is above the session name, or choose the full screen option to make this embedded screen larger. Now we will start this morning with Professor Stephen Handel, who is a distinguished professor of ecology from Rutgers, the University of New Jersey. Stephen is also the editor of the journal Ecological Restoration, which is where I found him after reading his editorials on the pandemic and climate change, which I thought would be a great fit for our theme. So Professor Handel graciously combined the two topics into a prairie restoration presentation for us today. The screen is yours.
Thank you. Good morning, everyone. Thank you for joining me. I'm sitting in sunny New Jersey. We're having a blizzard this morning, expecting about 70 centimeters of snow. I'm a plant ecologist, and over the last dozen years or so, I've gotten interested in restoration ecology, bringing back habitats which have been destroyed or damaged, the mission of your organization. I'd like to chat with you briefly this morning about change, and particularly climate change and public health change, and how these are affecting our dreams for better habitats throughout our continent, particularly in the prairies. You know, for most people, I think when we look out at nature, we see a static situation. It always looks pretty much the same year after year or decade after decade. This snapshot from the east shows three common kinds of habitats: forest in the background, pasture in the middle, and a wetland there at the bottom at the toe of slope. And year after year, if I went back to this site, it would look pretty much the same. Oh, certainly in dry years, that wetland might be a bit smaller. And in certain years where this spring is wet, more seedlings from that forest would invade the meadow. But it pretty much stays the same. Similarly with the great prairies in the central part of our continent. If you look at it, we say, well, prairies have been here since the First Nations covered the land. It's always been this way, and it's so important to us culturally, as well as for all the ecological services that prairies give us, as well as the biota around us. What can we do to understand and to restore areas which have been damaged or destroyed? Grasslands are terribly important. And I was raised in the East Coast, and I thought deciduous forest is normal. Well, it's not normal. What is normal on our planet are grasslands. In South America, most of the continent is grassland. Africa is mostly grasslands. Oh, we're raised as children thinking that Africa is jungle where Tarzan swings through the trees, but that's nonsense. It's only in the Congo Basin that it's jungle. And much of Asia, of course, and almost all of Australia. I put a little star where Saskatchewan is, just to show you where we sit in this great cycle of grasslands, which are most of terrestrial planet Earth. Well, what can we do in a world that's changing? This very simple diagram, well known to some of you, I think, shows how temperature and precipitation, rain and snowfall, define the boundaries of so many of our main biome types. Grassland is that golden shape towards the bottom. It can tolerate from very cold to warm temperatures, and it has a relatively low rainfall regime, less than usually 100 centimeters a year. This diagram shows where you find the biomes. It doesn't really reflect the amount of the surface of the earth that each of these biomes represents. In fact, grasslands, I just showed you, are much, much larger than deciduous forest or tropical rainforest. Well, what's going to happen to this distribution of habitats in our world, which is changing? And of course, this is the main fact which all of you should be familiar with. We as people have been adding carbon dioxide to our atmosphere at a very high rate. Oh, we're so good at doing that. And you can see the black line showing the concentration. I checked just a few days ago, and we're currently at 415 parts per million, much, much greater than at any time in the last several thousand years. And as this goes up, of course, it affects the climate. More concentration of carbon dioxide means the world is hotter. Carbon dioxide traps and holds heat near the surface. This is physics. It's a law of physics. It's not politics. It's not something that can be argued about. It's a fact of physics. And my friends, please don't argue with the laws of physics. It doesn't lead to a good ending. Well, what are we then as prairie restorationists going to do in the fact that our climate is changing and will continue to change as the political decisions to stop adding more carbon dioxide to our atmosphere are only very slowly being invoked? Here in the States, I think, as you know, the past government pulled away from the Paris Treaty, and it was only a week or so ago that the new president said they're rejoining it. That's the beginning, but it doesn't mean that we're going to stop adding carbon dioxide to the sky. So what will be the future distribution of these biomes, these habitats, in a changing world of climate? I'd like to walk through these diagrams with you. The top left shows the change of climate in the past 100 years. And up in the prairie provinces, as you see, the temperature has gone up about 2 degrees centigrade in the last 100 years. This is an enormous difference for living things. Up in the boreal forest and the tundra, it's even hotter. It's changed about 3 degrees. What does this mean for our main habitat types? Well, that's on the right side of these graphics. At the top, it shows the distribution of main habitat types in the recent past, 1961 to 90. And when you look up in Canada, you see, look around Hudson's Bay, tundra around most of the bay, then boreal forest. Boreal forest is actually the largest forest on planet Earth, as it goes around Asia and Europe. And below that, the beginnings of the prairie, that yellow that tucks into Alberta and Saskatchewan. And below that, mixed forest of deciduous and evergreen. All our best information suggests that these biomes will shift. And that's the lower right of this graphic. Again, look at Hudson's Bay. It's now will be surrounded mostly by boreal forest. And that mixed deciduous evergreen forest has moved up into southern Canada. Oh, your prairies, your grasslands have expanded, and you see that in the yellow in Alberta and Saskatchewan. Enormous changes in the distribution of the main biotypes, what it looks like to a layperson in the coming decades. We're already 2020, so this change is going to be incredibly rapid. Down in the States, of course, we're also getting changes. My friends in Southern California know that their warm, rather dry climate will change to the Chihuahuan Desert of Mexico in the next few decades. Incredibly dry, and the great fires of this past few years have proven that fact to them. Here's a close-up of another fact about the changing climate up in Canada. Each season gets hotter. The top left shows the winter temperature in your province going up about 3 degrees each year. This is from the Canadian government's most recent climate report. It's the newest information I could find. Every season is hotter, and the winter is much hotter. Of course, that's had an enormous impact on living critters, hibernating animals, diapause insects, dormancy in our beloved plants. All of these are affected by this hotter winter, and that changes the pattern of life, birth and death, as you'll see. Associated with this change in climate, there's also a change in precipitation. The newest government report of 2020 suggests that precipitation in the prairie provinces is going to go up by 5% in the next 10 years and by 15% by the year 2100, 80 years from now. Well, all that extra rain doesn't mean your ground is going to be soggy, because with the higher temperatures, you'll have much more evaporation and transpiration, and much of that additional moisture will go back into the air. Hotter and perhaps more stressed for moisture in the summer months, even with the greater amount of rainfall. These graphics show how in Alberta province, the habitats will change in the next 30 years. It's a rather garish diagram from your government. It looks like an explosion in a paint factory to me, but it is true. Look at the bottom. The yellow represents prairie, grasslands. And you can see the expanding distribution of grasslands as the next few decades move on. Saskatchewan, just to the east of the province, of course, will have a similar pattern of change. Enormous changes in habitat driven by changes in temperature and somewhat in precipitation also. How does this impact what we do as restoration ecologists, interested in restoring not just the ecological services of the prairie, but also its emotional, its cultural value to us, a sense of place, of what it's like to live in the great prairie states of this continent? Well, in addition to just the movement of biome types, climate change also affects processes, stresses. And this graphic shows some of the things which affect the entire continent. I've already talked about biome shift, but also insect distributions. The purple here shows bark beetles devastating many of the conifer forests in the west of Canada and the States. This is associated with these animals being able to move north to live in now warmer situations. Forest growth and mortality also was changed in the new stressful conditions. So the quality of the habitats changes in addition to the distribution of the biomes. In hydrology, changes in stream flows. In some areas, more water, and other areas, less. It's very hard to model small-scale hydrology because that is affected so much by landform and land use. And finally, wildfire, important for the long-term history of prairies and already sweeping at much higher rates throughout the habitats, particularly in the west part of the continent. All of these things affect function, persistence, sustainability of our habitats as they try to move in response to climatic changes. This graphic also focusing on Canada and its forests shows the kinds of forces which are changing with climate change. Aspen dieback, pine beetles killing evergreen trees, droughts in more and more areas, and so on. For animals like our migratory birds, this means wherever they go, they're reaching changed habitats, challenging their ability to persist through the decades. Our world is changing, and our restoration practice, alas, as hard as it is, has to change with it. Some detailed studies have been done of exactly what is changing and what the extent of that change is. Let me just walk you through a few facts of this big worldwide study. First on the left, plant species. The investigators studied over 70,000 species around the world. And look in the middle where it says 50%. About half the species in the next 80 years will suffer about a 20% loss in range. Range is the geographic area that one species covers. For insect species, similarly, about half the species, a little more than 25% actually, will suffer a loss of about 25% of its range. This is an enormous difference in the distribution of plant and insect species in the coming decades, changing the subtle biodiversity and species abundances within these communities. Oh, we'd like to think that, well, insects could move with changing climate, but it's not quite true. Again, on the left, this is similar to the last graph with a 2 degrees change in centigrade, which is a conservative estimate of what we're about to face. It might very well be closer to 2.5 to 3 degrees this century. About 20% of this plant species will lose more than half of their range. For insects, again, about 25% of the species will lose at least half of their range, but with dispersal, the blue bars, it only goes down a bit. Insects can fly, but not very far. And the speed of climate change is greater than the ability of our flying insects to match that. These are models based on the best estimates we have from around the world, but there's also data that shows what really has happened. This graphic, I'll walk you through it, is not a model, but it's a fact of what's happened in the last 25 years in Britain. These 4 groups, spiders, butterflies, beetles, grasshoppers, of course, very important in prairie in terms of overall functioning of the prairie, whether it's for pollination or for food for our bird community. The vertical solid line represents no change in distribution. 200 species were looked at, and as you can see, most of the species have moved northward, migrated north with climate change that has already occurred. The mean here, which is the dotted line, is about 50 kilometers north. 50 kilometers north of observed species movement for spiders, for butterflies, for beetles, and also for grasshoppers. And this is just over 25 years. To a biologist, this is an enormously rapid change in local distribution. And again, it's not a model. These are facts. This is what has already happened. Well, with the change of species diversity in these ways, the functioning of a prairie, in addition to our eastern woodlands, will also be affected enormously. Much of what I've chatted about is dispersal, the second category on the left. But with climate change, many other things are changing also. Species distributions are matched with species interactions. Different species move at different rates. And if you need a species to pollinate or other mutualists, they might not be present when your plants are flowering. The bottom left, demography, birth rate and death rate. These are enormously affected by temperature and rainfall, when birds nest, when plants break their dormancy, when seedlings emerge from the ground. All of these things are affected by local climate, small-scale climate. And as population dynamics change, birth and death rates, the ability of any one species to remain in your prairie project is challenged also. The upper right, evolution. Plants have mutations, as most animals do. And when natural selection acts on these mutations, it's a response to climate as a major stressor. Will mutations and recombination occur at the same rate so that our plants and animals can survive the rapidly changing climate? We're not sure yet, but we know the rate of climate change is so rapid, the proper mutations to allow an unchanging demography may not arise. Environment in this graphic is broadly defined, including human actions, land use. And of course, human populations keeps going up, urbanization keeps going up, land uses change, and this affects, as you'll see in a minute, what happens around our restoration projects, which are often of rather small scale. The enormous prairies of the past that the first settlers saw and the First Nations used for hundreds of years is long gone because we've changed land use in the prairie states. And finally, physiology, the ability for any one animal to survive well in a changed environment changes, just as you and I function differently when it's awfully hot out or awfully cold out. And this affects our ability to reproduce and to hunt for food and to do all the things which define our niche. And every species in our prairies has a subtly different niche. That's climate change, and I have to say that human ecology impinges on this also. This is a rather famous graphic from an early study done in Wisconsin, just southeast of you, and it simply shows the effect of human settlement and fragmentation from 1831 down to 1950 in this study. You see, what was originally a pretty continuous forest has changed, where most of the white in 1950 is us, our homes, our roads, our factories. The little black pockmarks are the remaining bits of forest. Well, with fragments like this, each of these pockmarks doesn't behave like the original continuous forest does. They're all stressed at the edge, warmer, drier conditions at the edge, not ideal for the plants and animals, including insects, which live in these little parcels, these fragments. And of course, with people all around these fragments, you have kids and yuppies on their mountain bikes. Nothing personal for you yuppies listening in. This also is another human-derived stress, in addition to the climate change, which is predominantly human-derived. Right? This is an overlay on top of just climate. Edge effects in these fragments, plus the climate change I've shown you the diagrams about, and of course with urbanization, the heat island effect. So much of the world is now urbanized, and all those buildings and roads and vehicles make the urban areas hotter than the surrounding rural areas. This is a triple threat, what one of my colleagues calls the perfect storm, changing and stressing our habitats, whether it's the forest of the east or the prairies of your province. All of these things are going to affect what's here, what's about to happen, and of course, the success rate of restoration practice. And of course, with all these heating effects, fire, so important for the historical prairie, also will change. Well, this gets to what I think is the greatest problem in restoration ecology. What is the practical target? What is the things we can do that will persist, be sustainable in that modern idiom for the decades ahead? Oh, I like this artwork. This poor fellow is coming back from a day at work. That's when people still went to the office to work. And he comes out of his subway stop and he sees the past. And this past, of course, is a carnivorous forest, or all these carnivorous age forest. These are all extinct now, of course. But what should be the past that we should restore to? Should we go back to our records of 100 years ago, when European settlement was first arising in the prairies? Well, we can't do that, can we? Too many changes, agriculture, people, fragmentation. Should we go back 50 years? We have very good quantitative records of what species and in what relative abundances lived in prairie remnants 50 years ago. Is that an appropriate target for the future? The future will be different. In my lab, we say never confuse the past with the future. And each of us in our own locations and projects has to decide what of the past makes sense to try to replicate in our designs and actions for the decades ahead. I have a suggestion, but we'll get to that at the end. I want to give you a few little experimental studies we've done that adds a little small key biological information to these concerns. And I think I'll start with pollination. There are many, many native bees in our fauna, thousands, of course, in North America, and they're beautiful and they're interesting and they're really not dangerous. I'll bet a nickel that no one listening in today has been stung by one of these wild bees. Of course, it's only the females that even have a stinger. Well, when we do our restoration projects, we need these bee species to pollinate are forbs, not the grasses, of course. They're wind pollinated. What's the hope of getting the pollination community back as we do our restoration projects? Of course, there are other pollinators. Bees are the most important, but we also have butterflies, leps, and flies visiting some of the other species. One of the most interesting studies I've ever read, and I'll show you here, is by Catherine Reed, who teaches just south of you in the University of Minnesota. And Reed looked at 8 prairies, 4 prairie remnants, things that had not been plowed and destroyed over the centuries, and 4 that were restored by communities such as yours. And she said, how many bee species do I find on these different 8 prairie locations? She found a total of almost 300 bee species. Good for her. She was a good entomologist. On the prairie remnants, she found 83 species that were only there. Only there. She never found those 83 on the 4 restored prairie areas. On the restored prairies, she found 73 that were not found on the original historic prairies. And she found 129 that were found on both. A very different fauna where she looked. And look at that huge difference between the heartfelt restored projects she studied, as well as the historic prairies, which had not been destroyed. The bottom 2 lines are the things that keep me up at night. Of all these species, 121 were only found on 1 of the 8 sites. That's how subtle, how idiosyncratic each of these sites were. And of all these 298 species, only 6 bee species were found on all 8. What this means to me is that even with the best planning, when we design a restored prairie parcel, we have no idea what bee species will be found there to service the plants that we all love looking at. Right? Microsite biodiversity changes from place to place. The ability to predict what bees will visit your restoration is a weak prediction. And as I like to say, you can't get these native bees from Amazon or from a Home Depot. These things have to move in from the surrounding landscape. The landscape ecology determines which of these species will get into your remnant. So you can add all the lovely wildflowers you want, but you really have no idea which of them will get the proper pollinators and make seed. Well, after I read this study, I got, of course, very nervous, and we did an experiment. And I just want to show you very briefly the results of that experiment. This is, it is a grassland, but it's totally artificial. This is here in the east. It's an urban landfill. Almost every city has a landfill where we dump our garbage. And they're run by civil engineers, God bless them. And they cover the garbage with some soil. And then they cover the soil with some grass seed. They hydroseed it just so the soil doesn't erode in the rain. This has a biodiversity of about 3. It's mostly fescue grass, which is easy and it's cheap to hydroseed in. And I went out there and said, look, this is terrible. It's a very poor habitat for any kind of wildlife. It's low biodiversity and has few services to people. And no one listening in would really want to take a nice walk with your loved ones through this. What could we do to improve it? So we put in some patches of native woody shrubs and trees to see if we could improve the local biodiversity on this old landfill. It's a big one. It was actually the biggest one in North America. And this is a very simple data set I want to report to you today. We went out to the plants we put in and said, are we getting bees here? Are we getting pollinators in this vast old urban landfill? And we simply recorded the visitors to the flowers and we made a collection and identified them with the help of bee biologists. And very briefly, this was the result. It was led by the project manager was Mary Yerlina from my lab. 3 restored sites represent plantings on these old urban landfills. And as you see, the number of what bee species is quite respectable, 51, 53, 30. And she also studied remnant habitats, preserves, which had the same species that we planted. and there a comparable number of bee species, 62, 21, 80. More to the point, the same proportion of flowers on my restored sites made seed as in the remnant sites, the natural populations in preserves and parks. A very optimistic finding that even though we had small plantings on a vast urban landfill, we would get some bee species coming in. And this shows, for you folks interested in this topic, the kinds of bees that came in. Bombus's bumblebees, they were 8% of the visitors. Almost everything else were these small solitary bees. Some of them, Hylaeus and Ceratina, are what we call tramp species. They do move rather broadly in the landscape. Almost no honeybees. My plantings were small honeybees, which have to provision large hives, didn't find enough forage, enough nectar here for them to be worth their time visiting my little plantings. The most interesting thing about this study, in addition to the fact we were getting dozens of wild bee species coming to these modest plantings, was the distribution of the pollinator movements. Here's a diagram showing an experiment that Yulina and I set up. We put the same plantings across this landfill site from the edge, 0 meters, to the middle, 350 meters from the edge, about 4 football fields. For you people who can't wait for the Super Bowl next weekend. And we also put the same plantings within a nearby remnant habitat, a small, modest forest, where, of course, there were bees, because that forest had been there for a very, very long time. And Yulina then studied what bees visited the flowers in each of these locations, and the results were really remarkable. And I'll just run through a typical finding on gray dogwood, Cornus racemosa, a flowering shrub. On this axis here on the left is the distance. 0 is the edge, minus 90 in the woodlot, and then towards the middle, 350 meters. This other axis at the bottom shows the kinds of bee species that we're visiting, and the vertical axis shows how many visits per every 10-minute sampling period. Well, one finding, of course, is optimistic. There's colors everywhere. We were getting bee visits almost everywhere. That's nice. The remarkable part of the finding is here, this high orange bar on the right. In the middle of the landfill, far from the edge, in a very non-intuitive way, we got a huge number of visits for each sampling period, almost the same as in the ancient woodland, in the old woodland. What was happening here in the middle? Well, we thought, of course, it should be going down like we saw in the other distances. Well, what happened here was a microsite problem. Right next to my plantings, there was some erosion, and the grasses that the engineers had put in had eroded away, and we had bare soil. Many bees nest in bare soil. They don't like to nest in the dense fescues because it's hard to dig down with that root mass. But where there was erosion, disturbance, the bees made nests, and of course, as they popped out, they visited the flowers closest to the erosion where their nests were. And we got a high frequency of pollinator visits in the middle of the landfill. What was an engineering failure was an ecological success. Something I've never forgotten. Well, I ran to the engineer who read the site and I said, congratulations, there's an erosion gully in the middle. We're getting lots of bees visiting our flowers. And of course, he said to me, there's an erosion gully? That's illegal. I got to send a crew in here right away and patch it up. We can't have erosion on the landfill. It's against the law. And he said, Stephen, there's bees? Who the heck wants bees? They sting people. I don't want any bees on my landfill. Ay, ay, ay. This is what it's like working with civil engineers. God bless them. They're well-trained, but not in ecology. And part of our work, of course, has to be to explain, to educate. Oh, I hate to say that. I'm a professor. I feel like I'm self-dealing. But we've got to explain to people the importance of these mutualists for persistence as the years go by. Well, of course, the answer was simply, of course, fill in your erosion gully, but would you let me just dump some sand on top of the landfill? Doesn't cost anything. And now we have these microsites for nesting. We put in 3 kinds of soil because different bees like different textures. And this works. This gives us the ability to attract pollinators because their nesting niche space has been satisfied. And this is cheap to do. The other thing I want to mention is another mutualist, mycorrhiza, those fungi in the soil which are necessary for plant health and persistence. The mycorrhiza have a deal. They get starch from the plant and they give water and nutrients to the plant. It's invisible to us, but it's important. And one of the most interesting studies of this mutualist in the soil was done by a group of investigators from Switzerland and Canada, University of Guelph, working together. It's a study which has had an enormous impact on my field. Historically, when we take ecology courses, we think, oh, it's competition. Stem banging into stem determines the number of plant species that can live in a prairie or even in a woodlot. But look at the findings. Start at the upper. I'll show you some of this. Look at the upper left. This shows the number of fungal species they put into their test plots. They started with sterilized soil. And the y-axis, the vertical axis, shows the diversity. As they added more and more fungal species, the diversity of plant species in their test plots, they had started with many seed, went up and up and up. The diversity of plants depended on the diversity of invisible mycorrhiza in the soil. The next graphic is similar, and this shows the shoot biomass, the weight of the above ground parts. And again, the more mycorrhizal species in the soil, the greater the biomass of the above ground grassland. Again, mycorrhiza are very hard to buy. You can buy bags at your local Agway or farm supply store, but it's really just one or two species in those bags. It's hard to commercially grow many species in abundance. Native prairies and forests have dozens and dozens of species, most of which you cannot buy. And this suggests another constraint on our ability to succeed in making biodiverse prairies in the years ahead, particularly as the climate is changing. Invisible mycorrhiza, a critical element in the success, our dreams for a sustainable future on the prairies. And the other thing I'll mention is no surprise to many of you is that to a layperson, you look at a meadow or a prairie and it looks sort of homogeneous, oh, pretty little flowers all over. But of course, when you look more closely, there are many microtopographical differences. Back in the prairies, of course, there are potholes formed by the last glaciation, making seasonal wetlands. And of course, this will change as temperature changes and the size and distribution of these wet areas in the spring changes. And that affects so much, particularly for migratory birds, but also other microsite differences caused by animals. Small gophers and prairies make these little mounds. And it's well known now that the bare soil these small mammals introduce are critical for seedling emergence and of certain of our prairie species. And bigger mammals too made changes, disturbances in the soil, which were necessary for certain plants to start new individuals and even new populations. Well, of course, these deer bison are not like they used to be, are they? One of our early human actions was to eliminate the giant herds which swept through the middle of our continent, and they were critical in creating the structure of our historic prairies. There's here and there are farms and preserves that have added back small herds, but the millions of bison of the past are gone forever. We have to try to restore prairies even without the action of a bison, a critical element of the past. Even other larger ungulates like these pronghorns have a distribution and numbers very different from the past. Of course, these animals work the prairie differently from a bison. They have thin, small mouths and more selective, and they change the relative abundance of plant species. We have changed the distribution and numbers of pronghorns, and it's very hard for us to bring back the historic interplay of these herbivores with the plant species we're so interested in. The final study I want to show you is this one of a beautiful butterfly of the West, Euphydryas editha, checker spots, very garish looking animal. It's about 2 inches, 4 or 5 centimeters across. And a long-term study was done, which again is another problem which keeps me as a plant ecologist up at night. The study was done on this grassland in Southern California, owned by Stanford University. It's called Jasper Ridge. It's a big preserve. Most of it is an open grassland and scattered oak woodlands around the edges, as you see. The study was done by Professor Paul Ehrlich, a famous guy. He's very famous internationally for his book, The Population Bomb. But before then, Ehrlich was famous as one of this continent's great lepidopterists, butterfly experts, and population biologists. Let me just walk through this graph, which again is very famous in my profession. This shows the numbers of butterflies on Jasper Ridge over a period of about 25 years. And no surprise, it goes up and down over the years. And of course it does. Some years are dry, some years are wet. That affects the numbers, the population biology of this one butterfly. And this is not a surprise. The carrying capacity changes year to year, and it averages between 1,000 and 3,000 over the long period. But Ehrlich, who's a clever guy, looked more closely. You study butterflies like this by netting them, putting a dot on their wings with a magic marker, and then releasing them. Mark recapture. And what he did was he said, look, it turns out these butterflies stay close to where they hatched out, and they don't go broadly across the whole preserve. There were 3 subpopulations on the preserve. In areas C and H at the top, you see these 2 subpopulations, they varied year after year pretty much together. Not always. You see in these years, one went up and the other went down. Other years, they went up and down together. In the third area, which he called G, was a different dynamic. They went down, and then they went up, then they went down, then they went up, and then they disappeared, and they never came back. What happened in G? Well, the story with G was that there was a subtle difference in area G. These butterflies normally feed on plantains. That's what the caterpillars eat. But in very dry years, when there's no plantains because they've shriveled, they move to a secondary plant species in the genus Orthocarpus. Area G didn't have that species, so when it got dry, the caterpillar starved to death, never came back. You and I, when we do our prairie restorations or woodland restorations, we do work with the major species, and we're happy enough if we can get them to grow. What this proved to me is that a minor, unimportant species, really an afterthought for most of us, is critical for full biodiversity to persist. Without that Orthocarpus, which is a minor element in the flora of Jasper Ridge, these butterflies can't make it. How many of us, when we do our palettes, our designs, look at all the species, even the locally uncommon or rare ones? And yet, of course, that's necessary to replicate, to restore the full biodiversity of the past. What looks like a homogeneous pasture there on the right is, in fact, a complex plant community, and the complexity drives the full biodiversity that we all dream about. Well, let me spend my last few minutes just talking about us, the human ecology component, particularly in an age of COVID. Oh, look at this picture, people working together, even touching hands. I remember when I touched people's hands. We're not allowed to do that anymore. It's dangerous. I've got an adult son. I haven't even shook his hand in the last 8 months because who knows what he's carrying. Well, you know, restoration ecology is a human activity. Our volunteer groups, our agencies, our companies that do this and under contracts. It's all people working together, and that is challenged by COVID. It's changing what we can do, certainly this past year and probably this coming growing season also. Groups of people are necessary in restoration, whether it's planting seed and flats to develop seedlings, planting them out in our project sites, measuring, understanding what we can do and eliminating the original imperfect habitats that we're trying to improve, and monitoring to see what's working and what's not working so we know how to plan better future grassland and prairie projects. All of this requires at least a few people working together, and look at them here. No mask, right next to each other. It's illegal for me as an academic to actually put a group of workers and students out doing this. It's dangerous. Monitoring, which we normally like to do year after year, we cannot do in situations like this. And finally, invasive control, something you'll hear a lot about this week at the workshop, is also something that usually requires teams of people. This group here is working right next to each other without masks, pulling up English ivy in a woodlot, an invasive here in the East which grows up trees, and it's a terrible problem. Well, this kind of a scene is simply crazy to do in the age of COVID. So all aspects of our human ecology and restoration have been challenged. Maybe we should just stop restoration for a few years till we're healthy again with vaccines. God hopes they work. The human ecology is changing with everything I've said about climate. So our world is different, and our actions as restoration ecologists in prairies and in woodlands must change for all these reasons. This was unpredicted, a fast change, and it has challenged our dreams of a better future. Let me just finish with these summaries. And working in grasslands and prairies, first, of course, we have to know about scale. What do you have to work with? How big is a patch? Knowing that if it's a small patch, not everything will be able to grow because of the stresses of fragmentation. Climate, as I've talked a bit about, is changing now and in the future in ways simply unknown. Again, the past will not be the future. Oh, what's around each of our projects? What are the threats, whether from people or from invasive species? Disturbances are needed. I showed you those a few pictures of bison and gophers, but fire, critters, those disturbances are all changed and often cannot be reiterated in our projects, particularly smaller ones near where people live and work. Management needs are unknown, and it's hard to get budgets and teams together to manage. Sometimes we'll get a grant from a government or a foundation to do a restoration, much harder to get the money to manage it for the decades ahead. The pallets, the species we put in, the sources of the past may be inappropriate for the future. Are we allowed even to bring in plants that grow south of where you work when they're not native now? Some groups don't like to do that. It may be necessary as our biomes are moving so quickly to the north. And of course, with disease, COVID this year, can we get teams, adequate teams working together to make our projects a reality? The interactions in prairie restoration are all changing. I showed you those graphics of range limits and how they're moving. For our plants, the germination, pollination, and dispersal rates will change as climate and mutualists appear and disappear with changing climate. Herbivores and pathogens also are changing. With a hotter world, survivorship and stress are getting worse, driving different community interactions among species. And of course, with our fear of working together, the interplay of us and restored prairies is also problematic, to be polite. Social constraints are even broader. And I think I'll end with this. Beauty in the eye of the beholder. Oh, not everybody loves prairies. I've learned that in my own work. Oh, there's bugs there and ticks. We'll get bitten. Maybe there'll be a small mammal there and I'll get rabies. We have to explain that prairies are more positive than disservices ecologically. Different strokes for different folks. Not everybody wants a prairie restoration. Hey, let's put in another strip mall. We can always use one more pizzeria in central Canada. Or maybe we'll put in a housing development. Then the mayor will get a few more tax dollars from property taxes, and he or she can have more money to support our schools. These are some things that we have to deal with. It's the human ecology of our projects. The numbers game, again, what species can live depends on the size of your project. I want to be alone, the great quote from Greta Garbo, the great Swedish actress who really was so talented and so beautiful, people bugged her all the time. She just wanted to escape. Well, it's hard for us as restoration ecologists to work with other disciplines in the government who are so busy and so overworked and so poorly paid. You come in and say, hi, I'm a local botanist. I want to change everything you do. And the answer I have heard often is, oh, Handel, I just want to be alone. Leave me alone with your new botanical ideas. And finally, the Beatles quote, here comes the sun. In a changing, hotter climate, we have to deal with what's possible. Return to the past is impossible. My last slide shows this lovely painting from the late phase of Van Gogh's career. I used to think this was abstract, showing this swirling dynamic nature. Now I think Van Gogh was right. This is an accurate depiction of the world around us, the dynamism, the movement, not the static, it always stays the same reality of older paintings of pastoral nature. Van Gogh saw movement and dynamics, and he was right. I sometimes think Van Gogh was a plant ecologist, not just a great, great post-impressionist painting. This is our world, changing, fluid, growing, and this is the kind of world we as restoration ecologists have to deal with. Not the simple, quiet, static past, but the dynamics of a new future. Well, thank you for listening. Have a wonderful week at this tremendous workshop. There's so much to listen to, so much to learn from, and I wish you an interesting and influential week to you all. Thank you. And I think I'll stop there.
Thank you so much, Stephen. We will enable the Q&A now. And so the questions will pop up on the screen. There's quite a few good ones.
Let me get back to your screen. Okay, I found you now. Should
Okay.
all remnant grasslands be viewed as bioreserves with greater value as bioreserves for greater? Well, listen, all grasslands have value. Even if it's not something that becomes a new national park for Canada, it's still something with great ecological services. All places that have plant and animal diversity represent areas that not just are good in themselves, but are sources of critters and seeds that can move out and enrich surrounding areas. So I'm going to say yes to this question. All remnants have values, not just for the little bit of the land that they're on, but for surrounding areas, which will have the potential to improve in the decades ahead. Thank you, Ross.
Okay, and the next one, the next two are about Microrhizae.
The answer is yes. Of course, this is not well studied in all species, but the poisons that affect higher plants also have an effect on many of the fungi species. They're not passive. Herbicides, good Lord, some of them even now we know affect human health. So they should be used with caution. Having said that, getting rid of invasive species is a high priority. And unless we can stop the onslaught, the tsunami of invasives in some of our projects, it's hopeless to do anything else. And I'd rather see a stress, a challenge, an insult to mycorrhiza than allow invasive plants to sweep through. Some people don't like to use chemicals. They like to just use mechanical treatments to get rid of invasive plant species. And you can do that in a small patch if you have enough hands and time. But it's really not possible in a big project. And alas, herbicides have to be used, and then you worry about phase two, bringing back the things that the herbicide might have killed that you would like to have in the future habitat. Thank you, Patricia, wherever you are. Information on pollen for narrow well, our next speaker actually might address this. The Xerces Society, which has a great focus on native pollinators and restoration, should be looked at. They have a website, xerces.org, and that's a good source, as well as your local agricultural universities, which often have entomologists with great local knowledge of what could be used. It changes from place to place. There's a lot of work done showing that narrow prairies and grasslands here in the east near farms have great value to improve pollinator service. And of course, more pollinators, the greater the yield. In my university, Professor Winfrey has studied this extensively. So there's a good literature on this. I would think the Xerces website is the great access to this literature, or a local entomologist. It's not something which is unknown anymore. Putting biodiverse prairie strips near farms is a very important value. Of course, it cuts down on the cost of mowing too, so you save a few bucks, as well as increasing yield. Thank you, Elizabeth. The question is about the biology of mycorrhiza, an area of active research. There's, hundreds of species. Some are very poorly studied. Some are cosmopolitan, Catholic. They will infect many plant species. Others are specialists. They're only found associated with certain higher plants. They move at different rates. We did another experiment with the movement of spores across the landscape. They move slowly. They move slowly. If you want mycorrhiza in your project, well, if you brought in soil from another prairie, I don't recommend stripping native prairies, of course. You'll bring in spores of some of them. Other than that, you just need time. Time is a great tool in restoration, as spores slowly are brought in, sometimes by the wind, sometimes with birds, and sometimes in the soil around the plants that you buy from native plant nurseries, and then they are already pre-inoculated with things. That study done by Professor Reed, I wish she had also looked at mycorrhiza in the soil. That wasn't her specialty. We now can identify mycorrhiza to the species just from DNA. Those techniques are available to us. And we're learning the distribution of numbers of mycorrhizae in the soil. So the formal answer is yes, some mycorrhiza develop faster to certain plant species. Others sit semi-dormant until their host plant, their mutualist partner, gets introduced into the prairie, and then they take off. They'll stay dormant for many, many years until the proper plant species is found. It's a complex interaction under active investigation. There's even a journal, Mycorrhiza, which where these new results are being reported. Thank you, Brianna.
That's an excellent answer. Next, we're going on to
I don't mean to agree.
Your thoughts on assisted migration.
Ay, ay, ay. Look, it's valuable. It takes, I want to answer this soberly. It takes a lot of people and a lot of time, and that often means a lot of funding to do it. Can we move species at a rate fast enough to match our changing climatic envelope? Can we do it at enough places so that we have nucleating centers, patches of native plants and varieties of native plants that will persist in the years ahead? I think it helps. I simply don't think we can do it at the scale large enough continentally to match the changing environmental envelope. I think we have to be frank and say that changing prairies, species, and ecotypes around us will be different in the decades ahead because we can't do assisted migration fast enough. It helps, but I fear in many habitats it may be a band-aid over a severe wound. When we look south for ecotypes that can tolerate warmer climates and even species whose climatic envelopes will be moving north, we have to give it a try. We have to find seed from southerly populations that can live in the Saskatchewan habitats for the next 20, 40 years. It helps, but I fear that we'll need more than assisted migration to have sustainable prairie communities 20, 40, 60 years from now.
Thank you. Next one is a little bit long. Did you want me to read it out? Or?
I can read it, thank you. Grain prices are high. Weather has been mild. Good for you these last few years. I've seen creation pushing bush and tilling cattail to dry wetlands. How do we educate grain producers on the ecology of these areas and how they relate to climate change? This is my business. I'm an ecology professor. Look, very few people study ecology. Let's be blunt here. Those people listening in are privileged in the sense you've been introduced to ecological services. That expression, eco-services, is not something most of our government officials, God bless them, have ever studied. Few people take biology at universities, much less ecology, a specialty. We have to keep talking about this at our public meetings in groups such as this Prairie organization and many others. Grain producers, we need them to grow our food. They're important parts of our communities and our food supply. But they have to understand that these microhabitats, prairie potholes, wetlands, are an important part of the future of our provinces and states for me. It just takes time. We believe in signage. We believe every time somebody buys a farm or a house, they should get a brochure from a group like the Saskatchewan Prairie Ecologist explaining the importance of prairie remnants and wetlands and giving us a healthier life. There's many studies now, I've written a bit about it, of how native prairies keep us healthier as humans in terms of a full species mix, stopping pathogens and diseases, even supplying critters that eat the mosquitoes that carry other diseases, not COVID. It takes understanding. We've got to change the curricula in our public schools and high schools, and we've got to get people who are past formal schooling to understand new understanding of eco-services. Look, native habitats are not just for bird watchers and people who love butterflies. They're important for the health of us all. And we've got to show that nature is important. It's not just pretty. It's a big part of our job. Thank you, Lyle.
Thank you, Stephen. The Saskatchewan Prairie Conservation Action Plan has a week of webinars every year about ecological services. And so it's the 4th year that we've been having it. And I think it helps to share information about ecological goods and services, but it's definitely
it's critical, and that should be done everywhere. Everybody listening in should give them a big donation.
Yes. This is our last question, unless another one comes in before you finish.
Do cattle play the ecological role of bison? No. No. They're different. I mean, they're different in such an interesting way, but they don't have the microsite influence. They don't have the foraging difference. They don't make those openings in the prairie that I showed that charming bison wallowing in. Look, there's so many interesting studies. Even when you put cattle on a pasture, changes the subsequent plant community. The migrating bison had one impact on the ancient prairie, historic prairies, as did wildfires. Commercial cattle and farming, ranching operation are different. Oh, of course, cattle will eat developing woody plant seedlings, so they play a role in freezing ecological succession, because they will eat many, not all, woody plant invaders, but they're not the same as bison. They're a rough approximator, and they're not the same as the original bison. There's very good experimental studies, the Kanza Prairie in Kansas and the Southern Prairie, which have shown this in large-scale experiments. There's an active role, I'm sure many of you are aware of, reintroducing bison as a ranch animal. Bison sell for a good dollar. Incredibly, there are bison farms here in New Jersey. Can you believe that? And the fellows who own that farm are doing very well. The meat sells for a lot because it's lean. He sells the hides, even the bones, for decorations and bars. And he's doing very well. And bison do better in the northern prairies. And they're easier to take care of than cattle, who are stressed by your often cold winters. So my formal answer is no, they're not a substitute. They're better than nothing. And I better stop there, my dear.
Okay. Thank you, Professor Handel, for your presentation. We really appreciate you joining us this week and sharing your insights with us. Next up, we have Dr. Stephanie Frischie, who is an agronomist and native plant materials specialist with the Xerces Society, as Stephen had mentioned earlier. Stephanie will be discussing pollinator habitat for habitat resilience.
Thank you, Caitlin, and good morning, everyone. I am also based in the States. I'm in Indiana, between Chicago and Indianapolis, at the eastern edge of the tallgrass prairie. And I've been working in the Canadian prairies since 2018 through a partnership with Cheerios and General Mills to work with growers and others who care for land in a program to create and enhance pollinator habitat in the regions that Cheerios sources oats from. So I will be talking about some of our opportunities in working landscapes for using native plants and protecting pollinators and other insects. I too wish we could be together. The PCAP meeting last year was one of my last trips that I did before the pandemic set in as well, but I am glad we have this remote option. And as Caitlin said this morning, I'll be talking about pollinator habitat and climate resilience with a focus on management and seed sourcing choices. And as I start this morning, I want to acknowledge and honor the indigenous communities native to the region of North America where I live. And I recognize that the current homes and farms and cities are built on indigenous homelands and resources. And those are of the Miami, Kickapoo, Potawatomi, and Shawnee people as past, present, and future caretakers of this land. Here's just a quick outline of what I'll go through here in this talk. First, some background information, then pollinators and insect decline, how climate change affects plants and pollinators, building on Stephen's talk, and also prairies, how they have inherent resilience, followed by ways to think about the choices we make as we are managing them, such as the seeds we use and other practices, and how those choices can further support resilience. I'll also talk about the Cheerios Xerces Pollinator Habitat Program and that opportunity for farmers and other land managers to add diverse pollinator habitat. And then just as a teaser or a reminder, at the end of my talk, the hour following that from 11:30 to 12:30, we have a discussion room to continue the Q&A and conversation about these topics. So a bit of background about the Xerces Society. We're an international conservation organization focused on invertebrates and their habitats. Xerces is celebrating its 50th anniversary in 2021. We were formed in 1971 by Dr. Robert Michael Pyle as an organization of butterfly scientists. And our name comes from the butterfly pictured here, the now extinct Xerces blue, which was the first butterfly to go extinct or to be lost to extinction in the United States due to human activity and habitat destruction in California. And Xerces was initially formed to prevent the extinction of other butterfly species. And in those 50 years, Xerces has really grown, and we now have over 50 staff across 17 different states, supporting conservation across North America, with programs in Canada and Mexico as well. Our work is categorized in several program areas. including pollinator conservation and habitat projects. That includes promoting agricultural biodiversity. We also focus on endangered species of invertebrates, such as certain bumblebee, butterfly, or freshwater mussels. We have a pesticide team who help us understand and apply current research in order to reduce the use and detrimental effects of pesticides, whether that's insecticides, fungicides, or herbicides. And we also work in urban conservation, community science, and we use restoration, research, education, and advocacy to further our conservation mission. In addition to our work on the ground and with many partners, we have a large and rich publications library. This is at xerces.org, and you'll find the menu where you can find the publications library, or if you just kind of do a web search on a topic and include Xerces' name in there, often you'll get good results that way. So these are all items available for free online as PDF downloads. And many of these resources include recommended plant lists, as well as guides for assessing pollinators and beneficial insects and their habitats, and how to manage those habitats. And I just want to also say thank you to Carolyn and Caitlin and Shirley for the opportunity to be part of this week's meeting and workshop, and also thank all of our Xerces supporters. We are a member-based organization, and we also receive support from many companies, foundations, and agencies to make our work possible. Okay. Getting into pollinators and invertebrates. So if we look here, this is just a pie diagram of all the animals that have been described so far on Earth. And again, much of our planet's biodiversity is still understudied and not that well understood or categorized. But what we do know to date is that 70% of all described species are invertebrates, and of those, the great majority are insects here. So there's a lot of diversity amongst our invertebrates. And of all that diversity, yeah, insects and invertebrates are important and wondrous in themselves, but they're even more important because of all the ecological connections and relationships and links that they make. They eat and move so many other animals and materials, and that's important to energy cycling and decomposition. Just yesterday I was out hiking, and there was a fallen log from a cherry tree, a black cherry tree, and there was a polypore kind of fungus on there. Those are the shelf fungi. This was a northern cinnabar polypore, so they're brightly colored and orange. And then I learned from another forest entomologist that there are hundreds of species of beetles that specialize on just eating that fungus after the fungus dies. And then, imagine all the other animals that are eating that beetle. So it's just one example of this connection between a plant species, the black cherry, this fungal species, the polypore, and then an insect species, all these beetle groups that are connected. Insects are also important in how much of a contribution they make to the diets of birds and other connected groups in the food web. And they're then finally, critical to reproduction for the majority of flowering plants that depend on pollination for fertilization and the production of seeds. And yet, So many studies, data, and observations overwhelmingly tell us that insect populations are seriously declining. Here on this slide, there's just walk through that. In the upper left is a little thumbnail image of the cover of a recent special issue in the Proceedings of the National Academy of Sciences on insect decline. I'm going to talk a little bit more about that later. But what's summarized here is from a 2019 article from Sanchez Bio and others, where they summarize the main causes of insect decline and then the associated actions that we can each take in our places, in our work, on our scale, whatever the size farm or yard or flower pot or prairie or ranch that we are caring for. And I think conserving and creating habitat is really at the heart of this. Quality habitat will not only support pollinators, it's also important for the natural enemies of crop pests. And adding habitat to farms, as well as a rotation of diverse crops, flowering cover crops, and other conservation practices create a more diverse farmscape. And really, diversity is at the heart of resilience. Reducing our reliance on pesticides, both through integrated pest and pollinator management, and by adding more habitat, which diversifies and kind of deconcentrates the type of plants that pests can eat, and also serves to attract and support fewer pests, and also allows larger and more diverse populations of beneficial insects to help manage those pest populations. It's also important to reduce our use and need of managed pollinators. And again, habitat works to support that because it allows all these wild populations of native pollinators to thrive and for all pollinators to be healthier and reduce the formation and spread of disease that can come through managed and stressed pollinators. So creating diversity through habitat is also a key tool in dealing with climate change. Diverse habitat is better able to withstand drought or extreme rainfall or especially late or especially early frosts. And perennial cover also helps to capture and hold carbon in the soil rather than having it be out in the atmosphere where it contributes to climate change. Also, just to get us on the same foundational page, what is pollinator habitat? We need to think of food sources, nectar and pollen, all throughout the active season from early spring through fall. Also forms of shelter, and this is in terms of nesting and overwintering sites, ways to, again, protect pollinators from disease and competition from managed bees. Connectivity and size is also important for pollinator habitat. The more small and isolated that habitat is, the less it's able to support and connect pollinators in their plant communities. And then again, actually being free from pesticides. There are both direct effects of insecticides killing insects, but then also herbicides are killing the plants that insects depend upon. Herbicides are also affecting the microbiomes, the gut microbes that live inside of bees' digestive systems and may also weaken or sicken or affect them indirectly and non-lethally. And when we talk about insect pollinators, we're talking about 6 main groups. So starting in the upper left, butterflies, and then to the right, moths. They begin life, an individual's life begins as an egg laid on or near the species' particular host plant, and eggs will hatch into caterpillars that feed on roots, stems, and leaves. And then the adult forms are drinking nectar from flowers and do some pollination in that stage of their life. Similarly, flies, as adults, a lot of flies are visiting flowers, but they're also a very diverse group, and their diets vary by species, where, again, adults may be feeding on nectar or pollen. Oh, sorry, that's my animation. But in the far upper right is a larva of a fly feeding on an aphid. You know, fly larvae also feed on other detritus or dung or carrion or other insects, as shown here with the aphid. Then lower left, like flies, the larvae of beetles have varied diets, and the adults of many species feed on nectar or pollen, and for that reason do some pollination. Wasps, many adult predatory wasps feed on nectar, but the adult females are hunting insect prey, which they feed to their carnivorous larvae. So wasps are another example of an insect group that's both a beneficial insect in terms of managing pest outbreaks as well as pollination. And then in the lower right is a bee, and bees are really the most significant pollinator. And this is because they actively seek pollen and collect it to take back to their nest and feed to their young larvae. And because of this, or for this reason, bees have very hairy bodies typically, and also special structures on their legs to help collect and transport pollen. This slide here gives us just a snapshot of the more than 4,000 bee species that are currently known or described in North America. And a lot of the pictures show the main groups of the wild native bees. If you look at the sliver of the pie at the top there, that represents bumblebees and the European honeybee, which again are probably the types of bees that most people are familiar with. But that's just one non-native managed species, and around 50 or so bumblebees, and yet that's only 0.1% of all the bee species in North America. So, as humans, when we're usually observing bees is when they are visiting flowers. Again, they're gathering pollen or nectar to take back to their nest. And the European honeybee is a social insect with thousands of individuals living and working together in a hive or colony. They're storing up honey as food to help them get through the winter. The native bees have pretty different nesting behavior from the honeybee. So bumblebees are also social in a way. Several bees from multiple generations help to raise young in their nests, which are these clusters of wax pots, as shown on the left. And again, around 1% of the native bees are bumblebees with this type of nest. Around 30% of our native bees make their nests in tunnels in hollow stems in a series of brood cells. And these bees work singly. They're single mothers to care for their young. And for that reason, they're known as solitary bees, or categorized that way. And then around 70% of our native bees are also solitary, but they actually nest in the soil, in tunnels or chambers. So it's not just flowers, again, that bees or insects need. They also need the right conditions for their type of nesting behavior. And then they're not overwintering as an active colony like European honeybees. They're either overwintering as pupae or adults that are huddled down in plant litter or other kind of protected places. I wanted just to go through these quickly, but again, talk about a few more images of these nests and these types of bees. So ground nesting bees need stable, untilled, undisturbed soil, but bare soil. Get my slide cut up there. Tunnel nesting bees, often if you're working with some of them, you've seen pieces of wood that have holes drilled in them, or you can use the hollow stems of grasses collected in a bundle or a box to build a type of nest box for them. But in the wild, they would just be finding the naturally hollow pithy stems from many herbaceous and woody plants to use. And then coming back around to bumblebees, again, they're making these nests that are clusters of round wax cells. And those nests are usually built in cavities, such as abandoned burrows, or maybe cavities in hollow tree trunks, or in brush or rock piles. And again, I talked a little bit about this before on the slide about pollinators, but beneficial insects, the way we humans are categorizing them by their function, they're primarily eating other insects. But this is all happening on or near plants and flowers, the leaves and roots, and often good pollinator habitat is also really good for many of these other insect groups as well. Okay, and now getting into pollinators and climate change. So this is a recent paper just from a few weeks ago, the past month, January, in that special issue on insect decline in the Proceedings of the National Academy of Sciences. And the thing I wanted to highlight from that paper was really that climate encompasses all these longer term patterns in weather events. And part of what is really challenging about understanding and trying to plan for climate change is that the ways climate is changing and what the biggest impact will be depends on location. It also depends on which aspect of climate we're looking at and how it's measured. In some cases, the high temperature or rainfall, the average rainfall, is getting higher. In some cases, those are decreasing or getting lower. In some cases, both are happening at the same place. And if we look globally at the average temperature, it's rising. Rainfall averages are also shifting up in some places, down in others, or it can be that rainfall is happening in more intense periods instead of being more evenly distributed as it has been historically, and just more extreme events. And that's the concept of variance, or variety, that climate is just more mixed up, especially, we may have a hot or cold spell really outside of the season when that would normally happen, like an early warm up, but then another cold period. And that's, again, all impacting the life cycles of these plants and insects, and part of how the environment is changing. And this is leading to range shifts, where the appropriate conditions for a species is shifting. Also, the phenological mismatch, when a flower might bloom, might be different from how the time when its normal pollinator is actually becoming active and visiting flowers. Just as some examples of that. And, here's a map looking at some temperature averages in North America and Europe. It's comparing a time period from 1901 to 1974 with a more recent period of the year 2000 to 2015. Areas shaded with yellow, orange, and red are where temperatures have increased. and which you can see, is almost everywhere, and especially at the higher latitudes in the Canadian north. And then there are some pockets or areas that are also getting cooler. And again, that's on average. This figure is also from that same paper, and this one shows precipitation shifts with areas in lavender and blue with increased precipitation, and the areas in yellow and orange and red shifting to lower average precipitation. So parts of the prairies are becoming drier, yet in the eastern prairies, they're becoming wetter with more precipitation on average. And this paper looked at bumblebees and the probability of site occupancy. So looking at how these changes in climate affect and the environmental conditions for bumblebees, how that affects those bumblebees. And they found that the probability of site occupancy declined on average by 46% in North America relative to that earlier baseline period. And that the probability of occupancy was decreasing, where temperatures rise above a species' upper thermal limit. That makes sense. However, that warming in regions that were previously too cold for a species is associated with an increasing occupancy. That's just another way of explaining how distribution ranges are shifting with that. Declines were also more likely in sites that became drier. So I just wanted to show these maps as a big picture and to talk about how plants and animals that live here and are adapted to temperature or precipitation patterns, that with these changes, the plants and animals are getting kind of nearer to the edge of the threshold of what they are or aren't adapted to and what they can or can't survive. And so an area may become too hot or too wet for certain species. And then, of course, there's all these associated and interrelated ecological interactions and relationships that are also affected and changing by this. Okay, so what about prairies, more specifically? So in many ways, I think prairies and grasslands are places of extremes. They have seasons of heat, seasons of drought, seasons of freezing, wind. I've got a misspelling here in desiccation, but that drying effect from wind and exposure. There's also periods of heavy rain or meltwater. And so in all the concerns over the effects of climate change, I think we can actually count a small blessing as prairies are somewhat inherently adapted to these extremes. But yeah, there are going to be changes, but prairies are not the most vulnerable natural community like boreal or coastal communities. And especially prairies can really be diverse places, and the more diversity, the larger the size, the more connected that they are, the more resilient they are able to change and maintain many of the species and ecological relationships. This is a graphic illustration of that concept. I mean, prairies have hundreds of plant species, but even in a pretty simple concept that's illustrated on the left, so you have a prairie with 10 to 30 plant species. There's so much more diversity of food and energy sources and the types of animals, from insects to birds to reptiles, amphibians, and mammals, and even fish, than what's possible in a quote unquote grassland that's just turf grass or a pasture of one or two tame species or farm fields that are monocultures. So yeah, getting more to where we are hands-on as humans, restoration or reconstruction of damaged or weakened prairies often includes adding seeds. We plant the seeds. And with that work, we're faced with decisions around which species to add, species selection, and then also which source populations of seed to use, whether we're drawing from wild or cultivated sources. Is it more local or less local? The terms provenance and origin are relevant here. Provenance is defined as really the location of the wild population and the associated genes and adaptations of that location in the population. Origin adds another layer really applied to cultivated seed. So say the provenance might be from Divide County, North Dakota, but it's collected there initially and then grown in fields for seed production near Red Deer, Alberta, as an example. And in that process, the seeds and the genes in that population may have lost some of its adaptation from the North Dakota provenance and develop more adaptation for the new Alberta origin. So sometimes those terms of provenance and origin are used interchangeably, but I tend to use them then differently like that, and they can be used to express the distinction I just defined. So yeah, this idea of adaptation, if we're going, to the work and expense and putting all of our hope in what is restoration and caring for prairies, we want each seed to have the best chance of growing and of becoming part of this natural community. So we want to match the adaptations between the source and the restoration site. And that's, why the local is better philosophy is valuable. However, as local climate and the plants and animals that do well in those conditions start to change into like a different kind of local, the plants can't move themselves as quickly or over some of the longer distances that may be necessary to keep up with changing climates. So our choices around provenancing become more important. And so really, I think, a good thing to think about is maximizing the adaptive potential. Local, as self-defined, you're kind of maybe just putting a radius of a certain distance from the restoration site. So strict would be a smaller radius, relaxed is a bit larger radius. Admixture and composite provenancing strategies, they combine local populations or provenances with more distant populations still within a species range. So composite is really trying to mimic natural gene flow. And then admixture goes a step beyond that and is including populations from farther away. And then kind of another category itself is predictive. That is really looking at the use of genotypes or source populations from areas that have similar climates as the one predicted for the restoration site. And then there's another one, I didn't write it here, but it's called climate adjusted. And I wanted to mention it also because that gets into the concept of introducing several non-local ecotypes that are sourced along a climate gradient. So again, it's looking at including higher genetic diversity and thinking about kind of building in adaptations to future climate. So this is an introduction of some of the concepts and terms around provenancing, and I hope we can talk more about these in the discussion room. And I also have more resources that I'd be happy to share via email. Two other concepts that we've talked about already in this morning's sessions is assisted gene flow and assisted migration. So assisted gene flow is just moving genes around within a species' current distribution. So depending on climate models, many or most of the provenancing strategies are a type of assisted gene flow, like admixture, composite, and predictive. And then assisted migration is introducing a species that doesn't currently occur in an area, but because of climate shifts, it's no longer going to occur in its current range. And it, again, may need human assistance to be moved to a climate envelope that it is adapted to. So again, lots of food for thought here, and I've just scratched the surface again. So I'm happy to talk more about this in the following hour here. Okay, I just want to pause here because now I'm going to transition into some of the action steps next. But I also want to acknowledge that there is risk in doing too little of this active management and also risk in doing too much, in terms of losing species or maladaptation. And then on top of that and underlying it as well is uncertainty. We only have so much information, and it's hard to know in some cases how pollinator populations are changing, because for so many areas and so many insect groups, they're really understudied to begin with. We also have multiple climate models, and they all may be predicting similar trends. But again, as we try to get down to our local scale, even if we have pretty good predictions, they may only be for the next 10 or 30 years. And then part of what our climate predictions are is just more variation and increasingly extreme events. And that again adds to uncertainty. I did also want to mention management. It's not just our seed choices that can help build resilience to climate change, but also some of our management. One restoration, about a 2,800 hectare restoration that I worked at in Northwest Indiana, part of that had constructed wetlands, and we made some of them actually very deep so that, even in especially dry or hot summers, there would still be water in those. So we're just trying to create a variety of wetland habitats there. Another management choice is just being more mindful of when and how prescribed fire is used, and how some of the refugia, the unburned areas, handle that, what the RH or the weather conditions are, and how that affects the intensity of the fire, and how that's shaping the plant and insect communities too. Okay, action. So here I'm just gonna quickly go through a few slides on our Cheerios Xerces pollinator habitat program. So we have a really great partnership with General Mills, and for Canada and the Northern Great Plains on both sides of the Canadian-US border, we have a 5-year project that's funded by Cheerios to work with growers and other land managers that are in the regions where oats are grown. I mean, oats are not an insect pollinated crop. They're an annual crop that's grown in rotation with a lot of other crops, such as flax and canola, which do benefit from pollinators. And it's just part of General Mills' overall sustainability approach and regenerative approach to build in more insect habitat in the areas where their ingredients come from. So this is an opportunity for any of you out there to add or enhance pollinator and beneficial insect habitat on your land. The program, essentially, I coordinate that program. You reach out to me, please, if you're interested, and I can talk through more details with you. There's an application form to go through. We've done some plantings that are smaller than 1 acre, and others that have been more than 100 acres. We use a variety of both tame species as well as native species. We've done some really exciting and diverse plantings with native prairie species, thanks to John Skinner of Skinner Native Seeds and Roblin for providing that material, as well as Kelly Leask and her business Prairie Originals around Winnipeg. And then we've also worked with companies like North Star and Imperial to source some of the tame species in that program. This is showing one of these participating farmers down near Boissevain, and he did mostly, a mixture of alfalfa and some other clovers, so tame species that were on the edges or some of these saline or marginal areas of his crop fields. And this was early in the first season, before they had begun blooming, but it's a nice example of one of those habitats. And we've also done some interesting work in partnership with pastures or paddocks near Brandon, Manitoba, with Manitoba Beef and Forage Initiatives. And Kim Wolf is there in the yellow and May Elsinger is in the red. They have a poster on this project here at the conference, so please take a look at that and learn more about it. But essentially, these were very species poor pastures that had lost their value for cattle and also for pollinators. So we did a couple different treatments, planting seed mixes with the species that you see here, and trying to see which methods work best for reintroducing some of this diversity into the pastures. And then there was a good question during Stephen's talk, just asking, about what's known about these strips in farmland. And this is a really exciting partnership. So we've got the private company, General Mills, providing the funding for this. Xerces is providing a lot of the technical support and helping with the seed mix design and doing the farmer contacts. And then we have Scott Beaton, the farmer pictured here from near Stonewall, Manitoba. And then we have a research project led by Yvonne Lawley and Jason Gibbs from the University of Manitoba. And so we're all working together in this really neat project where farmers participate in the Cheerios Xerces project, and we get those strips or edges or areas of habitat started. And then the University of Manitoba team comes out and they're doing sampling of both the insects as well as some vegetation transects to monitor, what's living there, what's growing there, what's flowering when, and then how far some of those insects or plants are moving out into the crop field. So I think we're just in year 3 of that. So there are some preliminary results, but we're learning a lot about that, and we'll be excited to present more of those results as we have them. And here's just a nice, I think, mosaic again, which shows a lot of the farmers and their habitats, and the research teams, and the seed producers, and the private companies that are making this partnership possible. And then, we don't all have farm or a prairie that we're responsible for. So there are also, this is from that same special issue on insect decline. There are 8 simple actions that individuals can take to help save insects from global decline. You can convert your lawn into diverse natural habitat. Anyone can grow native plants, even if you don't have a lawn. If you have a balcony or a patio where you can put pots of plants, you can choose pollinator-friendly species for those. We can reduce pesticide and herbicide use, limit the use of exterior lighting around our buildings and in our towns, which impacts invertebrate or insect behavior. We can also reduce some of the pollution that happens from our vehicles and our roadways. And then more around increasing awareness and appreciation of insects is to speak up and counter negative perceptions of insects, become an educator, an ambassador, an advocate for insect conservation, and get involved in local politics, support science, and vote. And also, I think in that last category, as Stephen said, kind of these research teams are not able to function in the same way during the pandemic, but any individual can go out and do some monitoring as a volunteer in a community science program. So one of those is Bumblebee Watch. There's a really nice app and website. You get to learn how to identify and recognize bumblebees in your area. You take photographs and upload them, and experts will verify what species they have. And that's really helping to build the body of knowledge around what species are where and how are those populations changing. Western Monarch Milkweed Mapper is also another opportunity to record what you see or observe about monarchs in all their life stages and when you see them, and also milkweeds and milkweed phenology. And iNaturalist is another great platform for individuals to learn and to share information about natural history and species distributions. And then just wrapping up, again, reminding everyone to please make use of our resources at the Xerces Society. We also have several books. These are not free. These are available for purchase or as a thank you gift if you become a member of the Xerces Society. We also have pollinator habitat signs that you can get when you become a member. So thank you to all of our donors and members who make our work possible. And finally, you know, there's a good saying, right, about the only thing that doesn't change is change. And we were talking here about climate change, and I think also about how we as individuals and communities can also be the change in a positive way here. Nope, let me get my slides caught up. Sorry, okay, that was the thank you to our members and donors. And here's the message about being the change. Thank you. Carolyn, you're muted for me.
Thank you. I was just saying, Stephanie, that was really great, and we really appreciate you being here today and sharing all this information with us. We will go through the questions now. There's quite a few, and I think some were asked early on in your presentation that you might have answered during your presentation. So we'll start near the end and work our way back up. So this is the most recent. Let me see. There we go. And would you like me to read them out, or would you rather just read it off your screen?
I think if we can all see them, I'll just try to quickly read it and then respond. Just a little time here. Yeah, so with our Cheerios Xerces Habitat Project, a lot of the participants do have cattle, and in some cases even bison, you know, bison as a livestock kind of animal. And that's also a really good partnership. Again, we're usually using some of these tame species, tame legumes that are good forage quality for those livestock, but also just changing whether it's haying, you know, allowing some of that pasture to flower and provide benefits for the pollinators, or managing the grazing intensity and the rotation on that. So we really try to adapt it to what each operation's goals are, and, you know, find the mutual fit there that works well for everyone.
Okay, thank you.
Okay, so we do go through kind of as part of the intake and getting to know the farmer, the land, the goals. We talk about, we do a pesticide risk assessment, essentially. And so in many cases, farmers who are interested in this program are already ecologically or agroecologically minded, and they're thinking of their farm and land as this system. And so they may be pursuing organic certification, or not pursuing it, but trying to follow organic production practices. But they also may have, you know, economic reasons and needs for using pesticides, herbicides, insecticides, and under certain conditions. So we talk through all of those things, and we just do try to minimize that risk. And that can be in actually like where we position the pollinator habitat, trying to put it in an area that's less likely to have pesticide drift on it. We also can plant or distance, like a spatial distance between that, or a more physical vegetative buffer. So, you grasses don't have the same value in terms of pollen and nectar for pollinators, but they're part of pollinator habitat. But just because grasses usually have fewer insects and pollinators in them, we can use grass or another kind of vegetation strip like that as another buffer between the really rich and diverse and flower-rich pollinator habitat and an area where pesticides might be used. Okay?
Yeah, sounds good.
Yeah, any suggestions for supporting ground nesting species? Yeah, I think it's important to just have areas of soil that are not disturbed, so not tilled, and at the same time that they're not totally covered in vegetation or crop residue or that kind of thing. I mean, many bees can find or make that, but that's why I like to include some of that basic biology about these different native bee groups is just to help us get started thinking about what are their needs in terms of nesting sites. So having places, whether it's in your yard or your farm or in your community where there's undisturbed soil, but is also bare. Also, for some of the tunnel nesting bees, they collect mud, and that's part of what they're using in their nest structure. So wetlands or little puddles are important for that as well.
Okay, great. The next question is from May.
Getting the ag community to adopt native prairie restoration is a harder sell than planting a hayland or pasture with numerous diverse legumes due to cost and perceived utility. Can you recommend or comment on the value of such plantings? Sure. Yeah, and I think this is where we kind of get into this continuum. If we look at the most diverse kind of grassland habitat on one end and a monoculture of a single crop in an annual system on the other end, there's this whole range of habitats that lies in between those two. And I think, as much as we can move towards the more diverse and complex and therefore resilient system, the better. So, even something that's hayland or pasture is in a way supporting more pollinators and more diversity than an annual monocrop field. But there is more cost, more commitment, really, in committing an area to a perennial native planting. I think we are learning a lot with this program and with the partners and the work that May and others are doing. We don't want those to fail, and they're not like planting a crop or a pasture. They have different water requirements. They take more time to actually grow. But I think, it's also another factor to consider is the economic part of it, right? That's kind of what we're talking about here as well. And some land is really on a micro site level, it may yield something, but is it really going to be providing income? It may cost more to try to farm, or like the previous question about trying to farm drier wet areas in these dry periods. I think, again, increasing appreciation and understanding about the long-term value of these habitats is important. And, in the States, we have some government programs that recognize that and help farmers pay or cover some of those costs of not farming their land. So, that's another part. I know in Canada, different programs like that are also available. So yeah, there's not one single answer, but kind of a multi-pronged approach to that.
Okay, thank you. Here's our next question.
How much effort is put towards commercializing locally adapted plants for pollinator mixes? Yeah, nice, good question. That's part of the work that we do at Xerces is again, knowing what the situation and the pollinator species are, what plants would they really need or benefit from, and then trying to find sources of those plants. So we work a lot with the native seed sector in trying to add more species like that to what they produce commercially so that they are available. And that, again, I think this question of local adaptation is important, and because sometimes we may decide that local is the most appropriate or what we want to use at a site. But in another case, it's still important, I think, to know that provenance or that adaptive potential that's in a seed mix, but we may want to use something from farther south, and plant that farther north to prepare, for future climate shifts and things like that. So there is effort and work, I think, both from our perspective as a conservation nonprofit in working with the companies to try to meet that need and bridge that gap.
Great, thank you. Here's our next question.
Are there any groups working on creating inventories on privately managed lands? Yeah, I'm sure there are, and I unfortunately, off the top of my head, can't list off what those are. Maybe someone else here in the workshop can comment on that. And if you're, I guess maybe the question is that you have private lands and you want to invite a group to monitor that. If that's the question, maybe someone else can follow up with Ross. Otherwise, some of these, there's a comment, multi-star, yeah, some programs are coming up there in the chat. But also a lot of these web-based platforms, again, I think like we've learned during COVID, there's pros and cons of doing stuff remotely and doing stuff online. And so a lot of these monitoring programs, you're in the place, you take a picture, you upload it, and all these specialists, wherever they are, can see your picture and help create that inventory of what's at that site.
Okay, thank you. If anyone knows of any groups working to create inventories and would like us to make a post about it in the lobby, you can contact myself or Caitlin, and we can put it up in the lobby for you. Our next question about biological control.
Yeah, again, as an invertebrate conservation organization, we are trying to help support people who want to reduce or eliminate pesticide use. And I think integrated pest and pollinator management is a great place to start. There are certain thresholds, certain reasons when chemical pesticides may be warranted. There's all these steps and choices and methods that can be used to try to just minimize the likelihood of a pest outbreak and of reaching those thresholds in the first place. So our pesticide team and a lot of our guidance around that works to support that. And again, the focus on habitat is really to support, I guess there's conservation biocontrol, and that's again trying to kind of set the scene so that insect populations can self-regulate and balance themselves. And then there's augmentative biological control, and that's the practice of buying in predatory insects and releasing them. We don't advocate for that model. There's a lot of problems and risks associated with that, but we do promote conservation biocontrol. We've got a really great publication called Habitat Management for Beneficial Insects, and so there's some really good guidance in there for farmers on that topic.
Okay, so we're out of time. So thank you, Stephanie, so much for your presentation. And thanks everyone for joining the climate session. Next on our schedule is the trade show, discussion groups, and the designated poster session. There are 2 discussion groups happening right now at 11:30. Stephanie will lead one group about pollinators and climate change, and Becky Magnus will lead a casual conversation about how you got involved in restoration and reclamation. There's also an open discussion group for like general networking. So if you're interested in joining a discussion group, when you're in the virtual platform, you go to networking, which is on the left side, find groups, which is at the top, and then choose the group that you would like to participate in. There's some groups that aren't live right now. There's one that's set for this afternoon at 3:30, but the other 2 are set to start at 11:30. There's a max of 25 people in each group, so it's first come, first serve. And so we hope to see you over there. Thanks again, Steph.
Thank you. Thanks, everyone.